I am Vigneshwaran, a senior secondary maths teacher. In this video, I am going to teach some basic concepts of trigonometry. I am sure this video will be so helpful to all the 10th graders. Usually, students feel that trigonometry is so tough, but trust me guys, it is not true. Trigonometry will be so easy and so interesting if you really understand its basic concepts thoroughly. So, watch this video till the end to master the basics of trigonometry. So, what are we waiting for? Without waiting anymore, let us get started. First of all, what does the word trigonometry mean? So, it is the combination of three words: trigonometry. Tri means three, gono means angle, metry means measurement. So, triangle means it refers to triangle. Metry means measurement. So, in fact, it is some kind of measurement using triangles, right? Actually, a triangle has three sides, as you all know, and it also has three angles. So, in fact, literally, trigonometry is the study of the relationship between the sides and the angles that are present in a triangle. Okay, so consider a right angled triangle ABC having sides x, y and z. So, here the angle B is right angled, and let us say angle C is theta. Okay, so as you all know, theta is a Greek letter and it is usually used to represent angles in mathematics. So now this angle is theta, and there are three sides in this triangle: AB, BC and CA, and this side AB is called the opposite side as it lies exactly opposite to the angle theta. And this side BC is the adjacent side because it lies next to angle theta, and this biggest side, which is just opposite to the 90 degree, is usually called hypotenuse. So this is the hypotenuse. Okay, so using these three sides x, y and z, how many ratios can be formed? Okay, there are 6 ratios that can be formed. Okay, these are the 6 ways of writing two sides in ratio form. Okay, so all these 6 ratios have some special names. Let us see the names one by one. So the first ratio, x by z, it is nothing but the opposite side by hypotenuse. See, opposite side by hypotenuse. And it has a special name, that is sine of the angle theta. Okay, this ratio is the sine of the angle theta. And now this ratio y by z, it is nothing but the adjacent side by hypotenuse, and it is called the cosine of the angle theta. Okay, see the next one, x by y, it is nothing but the opposite side by adjacent side, and this ratio is called tangent of the angle theta. Okay, see, this is sine and this is cosine. So this is tangent and this one is cotangent. So it is nothing but adjacent side by opposite side. So it is cotangent of angle theta. Next comes secant. So this is secant of angle theta, and it is nothing but hypotenuse by adjacent side. So secant of angle theta. And the last one is cosecant. So cosecant of angle theta is nothing but hypotenuse by opposite side. Okay, see, sine, cosine, tangent, cotangent, secant, cosecant. Okay, so what are the meanings of these words? Sine wave you usually learn in science. This is called sine wave. Okay, And tangent means a line which touches the circle at exactly one point. And secant, it is a line which cuts a circle at two different points. Okay, see, these names have been given to all these ratios with the sides of a right angled triangle. Okay, so now as you can see, this one and this one are the reciprocals to each other. Okay, x by z, and this one is z by x. So we can conclude that sine and cosecant are reciprocals to each other. Okay, so we can write sine theta is equal to 1 by cosecant theta, and cosecant theta is equal to 1 by sine theta. So in short we can write the sine as sin. Okay, and in short we can write cosecant as cosec theta. Similarly, the short form of cosine is cos, and short form of tangent is tan, and for secant you can write sec. Okay, and for this you can write cot. So we can write the reciprocal. Similarly, sine and cosecant are reciprocal, and likewise cos and secant are reciprocals to each other. As you can see, this is y by z and this is z by y, and tan and cot are also reciprocals to each other. This is x by y and this one is y by x. So we can write the remaining also like this. Try dividing this ratio and this ratio and tell me what happens. See, x by z divided by y by z. So this by z and by z will get cancelled, and you will end up getting x by y. What are you be doing here? So this is sine theta that has been divided by cos theta. You are getting x by y. X by y is nothing but your tan theta. So from this we can realize that sine theta by cos theta is equal to tan theta, and it is one of the important results. See, now another result from this, by taking reciprocals on both sides. So sine theta by cos theta, when we find the reciprocal, it is cos theta by sine theta, and we already knew that tan theta's reciprocal is cot theta. So this is your next result. Cos theta by sine theta is equal to cot theta. If this has to be theta, what can you say about this angle? So as you all know, in a triangle, the sum of all the angles, the sum of the three angles is 180. This is 90, and so therefore these two angles must add up to give 90. Okay, so if this has to be theta, this must be 90 minus theta. So in this triangle we have found sine theta as x by z. What can you tell about sine 90 minus theta? If 90 minus theta, this angle is considered, this angle A is considered, now this side becomes the opposite side. So sine theta is equal to opposite side by hypotenuse. So now the new opposite side is y and the hypotenuse is z. See, this y by z is nothing but your cos theta. So we can replace it by cos theta. So from this you can understand that sine 90 minus theta and cos theta both are same. Isn't that interesting? See, sine 90 minus theta is equal to cos theta. Similarly, in the same way, you can bring up the remaining results. So sine 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sine theta, tan 90 minus theta is equal to cot theta, cot 90 minus theta is equal to tan theta, cosec 90 minus theta is equal to sec theta, sec 90 minus theta is equal to cosec theta. Okay, so isn't that easy? Three most important identities in trigonometry. See, the first identity is sine square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. So now I will show you how these three identities have been derived. Okay, see, this is a right angled triangle, and so we can apply Pythagoras theorem. Okay, according to Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we can say z square is equal to x square plus y square. Okay, see, the hypotenuse square would be equal to the other two sides squares sum. Okay, see, now here let it be equation number 1. In this triangle, let us find out sine theta again, just as we found earlier. So sine theta is equal to opposite side by hypotenuse, so x by z. Okay, and let me bring this x to this side. Okay, whenever a number goes from one side to the other side, if it is in the denominator, it has to be written in the numerator. So z into sine theta would be your x value. Okay, similarly I will find cos theta's value. Okay, cos theta is equal to adjacent side y by hypotenuse z. Similarly I am bringing this z to this side, so z into cos theta is equal to y. Now let me substitute this x value and this y value in this first equation. First equation becomes z square is equal to, in place of x I am replacing z sine theta square, plus in place of y I am substituting z cos theta square. Okay, so this square is common to both z and sine theta. I can bring this square inside, z square into sine theta's square. Okay, so sine theta's square usually we write like this. Okay, for convenience we are writing the square of sine theta like this, sine squared theta. Let us do the same here, z square into cos square theta. As you know, you can take z square common outside, and it is sine square theta plus cos square theta, that is within the brackets. So if you divide both the sides of this equation by z square, you get 1, that will be equal to sine square theta plus cos square theta is equal to 1. So we have got the first identity. Isn't that interesting? Okay, similarly we can also get second and third identities. Like, let us say this is equation number 2. Now what I am going to do is I am dividing the second equation, full second equation, by, let us say, cos square theta. What happens? Can you guess? The full equation has to be divided by cos square theta. Okay, see, sine square theta by cos square theta plus cos square theta by cos square theta would be equal to 1 by cos square theta. Okay, cos square theta plus by cos square theta will cancel each other, you will get 1, plus sin theta by cos theta, it is tan theta, right? So there is a squared here, so tan squared theta is equal to 1 by cos square theta. 1 by cos square theta, already we know that 1 by cos theta is secant theta, so it is, there is a square here, so secant square theta, and hence the second identity has been derived. Okay, similarly if you divide this second equation by sin square theta, you will get the third identity. Just listen. See, sin square theta by sin square theta plus cos square theta by sin square theta, which is equal to 1 by sin squared theta. Okay, so sin square both cancel each other to give 1. Cos theta by sin theta, just before we learnt, it is cot theta. So here let us write cot square theta, which is equal to 1 by sin theta is cosecant theta, so we can write cosecant square theta, and hence we have got the third identity. Okay, so these three identities are very important in trigonometry. Okay, I hope you all enjoyed my today's video. I will see you soon with another interesting lesson. Till then, take care. Happy learning.